Hello and welcome to the Techlearners. In today's lesson, we will talk about approximation of the errors, which means we will learn to determine error using calculus. So let us see what we mean by error. For example, if we have been given to measure a line, let's say the length of a line, and its actual value is, let's say, given by x. So let's say this is on x-axis. So the actual length of the line is x. And due to some limitations of the measuring instruments, we somehow measure this to be x dash. So we have two values, which is x is called as the actual length, and this x dash which we have measured through any instrument, and due to the limitation of the instrument we have measured it to be x dash, which is the uh, experimented value, which is the experimented length. So the difference between the actual value and the experimented value will be termed as the error. So you can see this difference in between x and x dash, and this is indicated by del x, which is the small difference between the actual value and the experimented value. So we can define error as the difference between the actual value to the experimented value or observed value. So this is the error, and this error is defined as, let's say if the variable is x, so this will be defined as del x, where this actual value, let's say we have indicated it with x, and difference x dash. So this is how we define the error. So let's see, there are three types of errors that we need to measure. One is the absolute error, which we had just defined, which is to be del x, which is symbolized by del x, which is the difference between the actual and the experimented value. Then we have a relative error, which is defined by del x upon x. And then we have percentage error, which is defined by del x by x into 100. Now we will see an example that how we measure errors. Now let us see this example. Find by using calculus the approximation percentage change in P when E is increased by 5% and R is decreased by 2, and given P is related with E and R in the form of P is equal to E square by R. So we need to note here that we need to find approximation percentage change, which means we need to find out the percentage error in P whenever the percentage change in E and R is given. So as we all know that this is the formula for the power. So we will start with this formula. Let's have the solution of this. So this P is equal to E square upon R. We need to convert this formula into percentage error, which means in the form of del x upon x into 100, just to introduce this 5% increase and this 2% decrease. For that, we will take log on both the sides. So once we take log, so this is log of P is equal to log of E square upon R. And now we will be using the formula of log of m by n. We all know that log of m by n is written by log of m minus log of n. So on the right hand side this will be log of e square minus log of r. Again on the right hand side we'll use one more formula for the log, which is log of m to the power n is equal to n log m. So we'll apply this formula in this log of e square. So this will be twice of log of E minus log of R. So this becomes log P is equal to twice of log of E minus log of R. Now we'll be using the calculus and we will differentiate on both the sides. So on the left hand side we all know that differentiation of log of P is always 1 upon P. So this will become del P upon P. This is 2 is a constant, and for log E the differentiation will be del E upon E, and minus for log R we'll have del R upon R. Now as we can see, this is the formula for the relative error, del x upon x in the form. So this is del P upon D, this is relative error. Del E upon E, this is also relative error in E. Del R upon R, this is also relative error in R. But we need to convert this into percentage error, for which we need to multiply on both the sides by 100. So the left hand side will become del P upon P into 100. On the right hand side, the 100 will be multiplied in each term. So this will be twice del E upon E multiplied by 100 minus del R upon R multiplied by 100. Now we can see this becomes the percentage error in P. So you can see the formula del x upon x into 100 is the percentage in x. So here del P upon P into 100, this is the percentage error in P. This is del E upon E into 100, percentage error in E, and this is del R upon R into 100, percentage error in R. So these can be represented by percentage errors or change in the percentage. So now we come back to the question. It's given when E is increased by 5%. So there is a change of 5% in E, and this is a positive change which is increased by 5%. So in place of this percentage error, we will write 5. Okay, because this is the increase in E by 5%. Now on the right hand side, this is minus. Let's say what is the percentage change in R. So it has been given that R is decreased by 2%, so it's a negative change. So we have to write here minus of 2. So remember, for a positive change we always write it in a positive, and for a negative, that means decrease, we write minus of 2. So this becomes 5 into 2, that is 10, and minus plus, which is 2. So this becomes 12. Right. So this is the percentage change in P. So what is the percentage change in P? This is a positive 12, which means we have a 12% increase in P when E is increased by 5% and R is decreased by this 2%. So the answer is 12% increase in P. So we have approximated the percentage change in P. This is 12% increase in P. Let us see one more example on this error determination using calculus. So if the base radius and height of a cone are measured as 4 centimeters and 8 centimeter with a possible error of 0.04 and 0.08 respectively, calculate percentage error in volume of cone. So for that we need to use the formula for volume of cone, which we know that volume of a cone is given by 1 upon 3 pi r square h, where r is the radius and h is the height. So now let's take log on both the sides of this. So this becomes log of v, which is equal to, again this is log of 1 by 3 plus log of pi plus log of r square and plus log of h. So we are using that formula, log of mn is equal to log of m plus log of n. Now we will differentiate on both the sides. So on differentiating, this will become del v upon v. This is a constant, so for differentiation for the constant will be 0. This is also a constant, for differentiation for the constant will also be a 0. And this log r square, we will rewrite this as 2 log r. Log m to the power n is equal to n log m. So this is 2 log r. And the differentiation for this will be 2 del r upon r. Now plus this is log h, so this will be del h upon h. Okay. Now we can see that the radius is given as 4 centimeter and the error in radius is being given as 0.04 centimeter. So we need to find out the relative error for radius. So let's say the relative error for radius will be given by del x, which is the error is given 0.04. So this is 0.04 divided by the actual radius. Actual radius is 4 centimeters. So this is 0.04 divided by 4. This is equal to 0.01. So this is the relative error in radius. Now let's calculate the relative error in measuring the height. So the relative error in measuring the height would be the error of height. So this is 0.08. This is 0.08 divided by the actual height. Actual height is given by 8 centimeters. So this is 8. This will again be 0.01. So these are the relative errors. So let's substitute these relative errors. So this is relative error. As we know, this is given by del r upon r, and this is given by del h upon h. So we will replace these two here in the formula. So this is del v upon v, and we have to find out the percentage error. So let's calculate the relative error and then we will convert this into percentage error. So this is 2 into, now what is del r upon r? We have just calculated, this is 0.01. So this is 0.01 plus, now what is del h upon h? As we can see, this is del h upon h is also 0.01. So now this becomes, this is 2 multiplied by 0.02. So this is 0.02 plus 0.01 will become 0.03. So the relative error in V comes to be 0.03. But we have to give the percentage error. So just to convert this into percentage error, we need to multiply on both the sides by 100. So this becomes del V upon V into 100. This becomes the percentage change. This is 0.03 into 100. This comes to be 3. So as we know that this is 3%. So here we got the answer. The answer is what is the percentage error in the volume of the cone? So the percentage error in the volume of cone comes to be 3%.